Understanding the sklearn, Gaussian process, kernels, DotProduct kernel. The sklearn, Gaussian process, kernels, DotProduct kernel. Often referred to as the linear kernel in the context of Gaussian processes, is a fundamental kernel used for capturing linear relationships between data points. It measures the similarity between two data points based on their dot product. This kernel is particularly useful when the underlying function you are trying to model can be well approximated by a linear combination of the input features. Here's a breakdown of the dot product kernel and its significance. 1. Mathematical definition. The dot product kernel is defined as kx1, x2 by 1, x2 constant, where x1 and x2 are two input data points vectors. x1, x2 represents the dot product of x1 and x2. Constant is a hyperparameter that introduces a bias term. 2. Interpretation. Linear dependence. The dot product captures the extent to which two data points are linearly dependent. A larger dot product implies a higher degree of similarity between the input vectors. Feature importance. The dot product implicitly weights each feature according to its importance in determining the similarity between data points. Features with higher values in both x1 and x2 contribute more to the overall similarity. Bias term. The constant term allows the model to capture a baseline level of similarity, even when the input vectors are not strongly correlated. 3. Applications. Regression. The dot product kernel is effective for linear regression problems where the target variable is expected to have a linear relationship with the input features. Classification. It can also be used for linear classification problems, but may not perform as well as more complex kernels when dealing with nonlinear boundaries. Dimensionality reduction. The dot product kernel is used in some dimensionality reduction techniques, such as kernel PCA, to project data into a lower dimensional space while preserving linear relationships. 4. Hyperparameters. The sklearn, Gaussian process, kernels, dot product kernel has two hyperparameters. Constant default 1.0 controls the bias term in the kernel function. A larger constant increases the baseline level of similarity. Coa 0 default 1.0 controls the scaling of the dot product term. A larger Coa 0 increases the importance of the dot product in determining similarity. 5. Advantages and disadvantages. Advantages. Simple and computationally efficient. Easy to interpret due to its direct relationship with the dot product. Performs well when the underlying function is truly linear. Disadvantages. Limited in its ability to capture nonlinear relationships. May not perform well when data has complex interactions or when the target variable is not linearly related to the input features. 6. Example usage. Python. From sklearn, Gaussian process import Gaussian process regressor. From sklearn, Gaussian process, kernels import dot product. Define a dot product kernel with default hyperparameters. Kernel dot product. Create a Gaussian process regressor with the dot product kernel. GPR Gaussian process regressor kernel. Fit the model to your data. GPR. Fit X-train. Y-train. Make predictions on new data. YPRED-GPR. Predict X-test. 7. YAML description. Assuming you are using the sklearn, Gaussian process, kernels, dot product kernel within a scikit-learn pipeline and you want to save the pipeline configuration in a YAML file. The relevant keys would be YAML, kernel, class sklearn, Gaussian process, kernels, dot product. Constant 1.0 default value. Controls the bias term. Core or 1.0 default value. Controls the scaling of the dot product. This YAML snippet defines the dot product kernel with its default hyperparameters. You can modify these values based on your specific data and modeling requirements. In summary, the sklearn Gaussian process kernels DotProduct kernel is a powerful and versatile tool for capturing linear relationships between data points. It is simple to use and provides a good starting point for many machine learning tasks, especially when dealing with data that exhibits strong linear dependencies. However, it's essential to consider its limitations and choose other kernels if nonlinear relationships are suspected.